Welcome to Let's Talk Micro. Hello, everyone. Welcome to another episode of Let's Talk Micro. As always, I hope you had a great week. And you can always find Let's Talk Micro on Apple Podcasts, Spotify, Amazon Music, Google Podcasts, Stitcher, Pandora, TuneIn Radio, GoodPods. Whatever you listen to your podcast, you can find Let's Talk Micro. As far as social media, I am on Instagram as Let's Talk Micro, no apostrophe, on Twitter as Let's Talk Micro 1, on TikTok as Let's Talk Micro, and on LinkedIn as Luis Plaza. So go ahead and subscribe to the podcast. If your app allows you, go ahead and leave a review. That's always good for the podcast. And definitely go ahead and follow on social media. I always like to post pictures of organisms, give updates as to when the next episode is coming out. So definitely any feedback is always welcome and appreciated. And if you think of any good topics, or if you think you could be a good guest, go ahead and email me at letstalkmicro@outlook.com. So definitely follow, subscribe, and leave any feedback. If you haven't checked out the previous episode of Let's Talk Micro, please go ahead and do so. So I went over the genus Bacillus. They are large, gram-positive rods, and we hear the term boxy that is used for them. And this is because they have a square shape. And I definitely told, students out there that start associating these terms, with the gram stain is definitely helpful, especially if you have some sort of, case study when you're taking an exam. We have learned about arrangements, cellular arrangements. So, we know about your chains, your tetras, your clusters. And definitely when you're dealing with gram-positive rods, you hear terms like boxy, long and thin, coroniform, short rods. So definitely keep that in mind. You also hear branching. So keep those in mind. Associate them with the organism. So definitely with Bacillus, we use the term boxy because they do have a square shape and they're larger than other gram-positive rods. So very large. And then I definitely talked about how they can stain variable, right? So sometimes, you get those colors. Maybe the same cell has like a little bit of pink, a little bit of purple, reagents that are used in gram stain. Or you can have some cells staining purple, some cells staining pink. But definitely, due to the age of the culture, they can stain variable. So if you have an older culture, you get that variability. And also because of the spores. And I did talk about spores. So remember, the purpose of spores basically is survival. So when the organism, is subject to extreme conditions, you have like high temperatures, there are no nutrients, there's desiccation. So the organism produces spores, and then basically everything they need to replicate, it's in the spore, and then when conditions are more favorable, they will resume their normal activities. But they can survive for long periods of time. And then I also mentioned that with the spores, right, when you are looking at them on the gram stain, you see like a white clearing, because it's not staining. But I did mention that you can also use malachite green, where the spores appear green, and they can also be induced by heat. As far as media, you can also use media to induce spores, and so you can incubate the organism in triple sugar iron agar or urea agar, and also some agar that contains 5 milligrams per liter of manganese sulfate. So that can be used to induce spores. And you have several groups, and I spoke about groups, right? So remember, this is regarding Bacillus. So you have, several groups. And I did mention that in microbiology, it is common where certain organisms, they are put together, and then you get these groups or complex. I mentioned Enterobacter colloicae complex, Burkholderia cepacia, Bacteroides fragilis, Staphylococcus aureus complex. So you have several organisms. So I did mention that with Bacillus, you have several groups. So you have the Bacillus cereus group, you have the Bacillus subtilis group, and you have the Bacillus circulans group. So from the Bacillus cereus group, you have Bacillus cereus, which can be very significant, and it is implicated in food poisoning. And once again, students out there, remember the fried rice poisoning. So definitely, it is seen in a lot of cases where rice has been ingested. So remember that when you are taking a test, like at an exam for school or one of your boards like the ASCP, keep that in mind. So, it is fried rice poisoning, like I said, because a lot of cases have involved the ingestion of rice. Also, another disease associated with Bacillus cereus is endophthalmitis, which is an infection of tissues and fluids in the eyeball. I also mentioned that two members of another group, this group being the B. subtilis group, they are also implicated in endophthalmitis. And those are Bacillus subtilis and Bacillus licheniformis. And then you have another member of the Bacillus cereus group, which is Bacillus anthracis. And like I mentioned, that's going to have its own episode. So definitely, if you haven't checked it out, go ahead and do so, because today's episode it's building up into that. So we already mentioned groups of Bacillus, we talked about gram stain. So now we are going to talk about media, morphology, and biochemicals. So in the lab, how do we identify Bacillus? What kind of media does it grow on? I mentioned in the previous episode that they are aerobic or facultative anaerobes, and they actually grow well in your standard media that is used in the lab. Of course, media that is selected for gram-negative rods is not going to grow there, of course. But the other media, like your blood, your chocolate, your PEA, your CNA agar, Bacillus will definitely grow on. So as far as being team players and not being fastidious, they are definitely great team players, and they will grow on your standard media. Then as far as morphology, it is varied. So Bacillus cereus, it has large, spready colonies that are beta hemolytic. And when I say large, I do mean large. And they have like a waxy appearance, and they almost swarm. So if there's a large number of organisms, and those of you that when you subculture it, you definitely know that even you grab a tiny bit and then you just subculture that, and then you get a lot of growth. And then those colonies, they will definitely grow over others on the agar. So if you have a Bacillus and there's something that you're trying to get out, go ahead and get it out as soon as possible, because that Bacillus, more than likely, it will grow over it. So another member of the Bacillus cereus group is Bacillus thuringiensis, that I mentioned before, and the morphology is about the same. Then as far as Bacillus subtilis, it has large, dull, waxy colonies that may or may not be hemolytic. So definitely, as we go along, remember hemolysis and how does that relate to Bacillus anthracis. Then we have Bacillus licheniformis that has large colonies that are beta hemolytic. There is also a member of the Bacillus cereus group that I didn't mention, but I am going to because of the morphology. And this is Bacillus mycoides. And I want to mention it, like I said, because of the morphology, because the colonies, they're rhizoid, and they almost resemble a mold. So I know definitely that some of you that work in the lab, you might have seen it and perhaps thought that it was a mold, right? You typically, when you have a mold, you see it, it looks like a little fluffy, a little hairy. And this species is actually, it's like that. It has like that hairy looking morphology. So you might definitely think it's a mold. So definitely remember it in case you ever see it in the lab. That doesn't mean that you have a mold. You might have a Bacillus. Of course, with time, repetition, and looking at things over and over again, you definitely get familiar enough where you can tell them apart. But especially if you're coming in new, maybe a little bit inexperienced, just starting your work, you see one of these, you might definitely mistake it as a mold. Of course, you cannot just call something, we have to do testing such as gram stains and other things. But at least visually, that can happen. So as far as motility, most species of Bacillus, they are motile. And this is also important when it comes to Bacillus anthracis. And I will talk about motility when I do the episode about Bacillus anthracis. But basically, motility is movement by means of flagella. As far as biochemicals, they are catalase positive. Other tests, they include fermentation of sugars and indole production. But as far as testing that you do in the lab on the bench and stuff like that, even though you do see the fermentation of sugars and the indole production, that's mentioned in the textbooks, so we mostly do the catalase and we do the motility. The motility being very important when you have a non-hemolytic bacillus. But let's go ahead and talk about media. So I mentioned how significant Bacillus cereus is and that it can be found in food. So you definitely have agar that is used to detect it in food. One of them is mannitol, egg yolk, and polymyxin B agar. And this is abbreviated MEYP or MYP. So I am going to talk about MYP agar from Hardy Diagnostics, which has no affiliation with the podcast. So as the name says, it has polymyxin B, mannitol, and egg yolk lecithin. Additionally, it has nitrogen, vitamins, minerals, and beef extract. Mannitol is the carbon source for this agar. So if the organism ferments mannitol, the colonies will turn yellow. If it's not a fermenter, if it doesn't ferment mannitol, the colonies will be red. And by now, with the episodes that I have done, you're definitely familiar with how the process of fermentation works. So, when fermentation, so if the organism ferments that sugar, acid is produced. So you do have an indicator in the media that measures the changes in pH. So in this case, it's phenol red, which is also used in a triple sugar iron agar, which definitely go ahead and check out that episode if you haven't already. So you have phenol red as the pH indicator. And I mentioned mannitol, and I know those of you in the lab, definitely you're familiar with mannitol. There's a popular agar that's mannitol salt, which is the same, it's the same principle. If the mannitol is fermented, it turns, the colonies are yellow. So this is what we're seeing here with the fermentation. We see a color change. So the medium has polymyxin B, which inhibits the growth of normal flora. And then organisms that produce an enzyme called lecithinase, that enzyme that hydrolyzes the lecithin that's in the egg yolk agar. This results in white precipitates around the colonies. Bacillus cereus does not ferment mannitol, but produces lecithinase. So the end product of this agar should be pink to red colonies with white precipitates around the colonies. And this is a very simple procedure. You inoculate your sample on the agar and then incubate it for 18 to 48 hours at 30 to 35 degrees Celsius in a non-CO2 incubator. So you need to incubate the plates aerobically. So then you examine for Bacillus cereus colonies, and they are pink to purple with a zone of white precipitate. It is recommended that the colonies are identified by procedures such as molecular procedures, or as mass spec, such as the Molotov. There's another medium that is polymyxin B, egg yolk, mannitol, and bromothymol blue agar. And this is abbreviated as PEMBA. Fisher Scientific sells some, and also Lyophil, which is an Italian company. I don't know if you out there, maybe you're familiar with Lyophil, but they do make some e-tests, and they're coming along with making some broth microdilution tests. And then the e-test strips that looks like they're like kind of like cardboard. They have like that cardboard look. So I don't know if you use them or not. I think all of them are for research use only. But definitely you might be familiar with them. So it's Lyophil, and once again, no affiliation to the podcast. So with this medium, with PEMBA, so the principle is the same, right? So once again, you have mannitol, which is for the fermentation, and then you have lecithin from the egg yolk. So as I mentioned, with the MYP agar, Bacillus cereus does not ferment mannitol but hydrolyzes lecithin. So with the PEMBA agar, you will expect to see the white precipitation because it will hydrolyze it. However, the pH indicator for this agar is bromothymol blue instead of phenol red. So instead of having pink to red colonies, if the organism is not a fermenter, you will have blue colonies. But if it ferments mannitol, then you will have yellow colonies. And once again, keep in mind with this media that this is used to detect Bacillus cereus in food. So it's, you have your samples are from food, which, definitely makes sense because it's an organism that's seen, it causes food poisoning. There is also chromogenic media, which is also used to detect Bacillus cereus in food. And there is one by Fisher Scientific that is called Brilliance Bacillus cereus agar. And this one actually has a chromogenic substrate, which is, and bear with me as I go through it, 5-bromo-4-chloro-3-indole beta-glucopyranoside, which is cleaved by the enzyme beta-glucosidase that is present in Bacillus cereus. And this results in blue-green colonies. It also comes with a supplement that has polymyxin B and trimethoprim. And trimethoprim, it has activity against Staph aureus, Enterococcus, and other Bacillus species. So the plate, is inoculated at 37 degrees aerobically for 24 hours. Once it's ready, then you examine for those blue-green colonies. You also have, other chromogenic agar, and this is which uses the phospholipase C activity. So as far as instruments that identify Bacillus, so you do have, like the Vitek and the Molotov. They do identify them, and actually Vitek has a Vitek 2 systems. They have a card that is called the Vitek BCL card that identifies Bacillus. But to be honest, I have never seen it in any other places that I have worked on. There are also API tests that identify Bacillus. I haven't worked with them. As far as API, and I think maybe some of you in the audience, I don't know how much they are used outside of the United States. In the US, we use them, but as we start moving towards Molotov and other things, we might just not be using them anymore. But I did work with the API test, like the API E, 20E, and 20NE, the 20E that you use it for Enterobacterales. I was never a fan of that test because, it's definitely, it's involving, you have to go ahead and make your suspension, make sure that you fill the little wells, then you incubate it, add your reagents the next day, and they work well for your classic organisms. But when you have something that's a little unusual or abnormal, they might not work well. And I'm not a fan of tests that you see some reactions, you get a number, and then that combination of numbers gives you a result. Like this 4-hour kits that you use for anaerobes, because they can be very subjective, and then you can start, maybe have a positive, maybe have a negative reaction. So you can play around with the numbers so you can get the result in a way. So it's just not, I don't know, I don't really like it. I prefer things like the Vitek or the Molotov, which in my opinion, they give you a more accurate result. So I mentioned the Molotov can identify it, but the identification can be affected by the spores. And while we're talking about systems, this is something that you have to make sure that as as a microbiologist, especially as a upcoming microbiologist, that you just graduated, you're starting your job. When you are setting, using these instruments for ID, you have to make sure that the organism, it's in the database. And this is something that I've seen with moldy users. That you put your organism in, you get an identified, it fails on the moldy, and you're like, okay, well, let me go ahead and put it on the Vitek. Or the same thing, you get an ID that's questionable on the Molotov, and then you said, okay, let me put it on the Vitek. So basically, you're trying to confirm something or identify something, but you have to make sure that if you're using that particular instrument or that particular card, you have to make sure that the organism is included in it. And this is very simple, especially, Vitek users. You can go online and you click, for example, gram-negative ID card package insert, gram-positive ID card package insert, and then check if the organism that you are trying to confirm that name is actually in there. If not, then don't use it, because you might get a different result. You might get some sort of misleading result. So this is something to keep in mind when you are trying to identify anything. Make sure that particular test or instrument actually has that name included in the database. So in the lab, beta hemolytic species of Bacillus, and just going back to the Vitek real quick, your GP card doesn't identify Bacillus. So if you're trying to go that way, don't use it for that. So in the lab, we can presumptively identify beta hemolytic species based on the gram stain, morphology, and catalase. And I'm definitely going to talk about, like I keep mentioning, I'm going to talk about Bacillus anthracis in a separate episode. But if you see a beta hemolytic Bacillus, catalase positive, gram positive rot, you can go ahead and call it Bacillus. So, and I talk about presumptive IDs, which typically, you can call the organism, you can, identify it based on certain criteria, right? A very common one is E. coli, where you have a lactose fermenter, flat and dry, indole positive. You can call it E. coli. But with Bacillus, you can apply this criteria. If your Bacillus, if your suspect colony, it's not hemolytic, then you need to do a motility test to rule out Bacillus anthracis. Bacillus anthracis is non-hemolytic and non-motile. And like I keep mentioning, I will talk about motility on the episode about Bacillus anthracis. So let's go ahead and bring it all together so we can have it all nice and summarized. So definitely, with Bacillus, we have talked about the gram stain, we have talked about spores. As far as the colony media, it grows on your regular media that gram-positive grow on, your blood, your chocolate, your PEA, your CNA. So it grows there. Colonies, you can have different morphologies, but typically they are large, they are spready, and then you have hemolysis, and some may not. So definitely, I talked about Bacillus mycoides, which has the rhizoid colonies, so it looks like a little hairy. So definitely, if you're listening to this episode, go ahead and Google it and commit that morphology to your memory, sorry. So definitely keep that in mind. And then, we talked about media. So typically, the medium that you use for Bacillus cereus in food. So it has mannitol, which, if it's fermented, you have a pH indicator. And then fermentation is yellow, and depending on the indicator, if you use phenol red, you have red colonies. If you use bromothymol blue, you have blue colonies. And then if the organism hydrolyzes lecithin, you get those white precipitates around the colonies. So if you're a microbiologist out there that works in the food industry and you work with this agar, go ahead and send me an email and we can discuss the possibility of doing an episode where we can talk about that. It's very interesting seeing this agar, and how it works. But like I said, that medium is used for Bacillus cereus in food. So keep that in mind. And definitely, we talked about how to presumptively identify Bacillus, colonies beta hemolytic, catalase positive, you can call them Bacillus. And some of the instruments that you work with in the lab, such as your Vitek and your Molotov, they can identify Bacillus. And that, my dear audience, it's the end of this episode. I hope you enjoy learning about Bacillus, about media, biochemicals, morphology, testing. As always, I enjoy sharing this information with you. Continue bringing that passion to what you do. We do such great work. So bring that motivation, bring that passion. Thank you everyone for always listening. I will continue bringing good stuff your way. So as always, stay motivated, stay safe, and of course, continue talking micro. Until the next time. Bye.